Okay, in this video tutorial, we are going to be solving a system of equations by graphing. The difference here with this one, you have one of these equations that's solved for y, which means it's in y equals mx plus b form, or what we call slope-intercept form. This equation is not in slope-intercept form. So the first thing I'm going to do is to convert this equation, x plus 2y equals -4. I need to put this into slope-intercept form. Well, I need it to say y equals. So what I'm going to try to do is isolate this y. First of all, I have this x. So I need to remove this x. The way to remove a positive 1x is to subtract a x, a 1x. That means we have to subtract x over here. But like I've said, this does not say -4 minus 1. It says -4 minus 1x. They're not the same. They're not like terms. They're not on the same team. But we just represent it by saying our equation now says 2y equals -x minus 4. So what I did is I just brought down the -x and the -4 down here. Okay. Now, we are in y equals mx form, but we have a 2y, and we need that to be 1y. So what we're going to do is we're going to divide by 2. But you have to divide everything by 2 to keep an equation equal or balanced. Now, of course, 2 divided by 2 is 1. So the left side now says y equals, which is what we were trying to do, solve this equation for y. Here we have a -1x over 2, or divided by 2. We'll just write that as a fraction. That's -1/2 x. And then we have -4 divided by 2. Well, a -4 divided by 2 is -2. All right, so that's now the same equation as that one, but it is written in slope-intercept form. So we have two equations in slope-intercept form that we can graph, okay? Let's go ahead and start with the one we were just working on. It says it has a y-intercept of -2. So we can come over here and put a point at -2 on the y-intercept. Remember, the y-intercept, or the y-axis, is when x is 0. We just go 0, -2. All right, now it has a slope of -1/2. Okay. A slope of -1/2 really could be written like this, okay? We don't know, it doesn't matter necessarily if the negative goes with the 1 or the 2, but one would be negative and the other one would be positive in terms of rise and run. So if we call it -1, then we would go down 1 and we'd have to go to the right 2 units for positive. So -1 over 2, and put our next point, and that point would go right there. And then we could continue doing that, down 1 over 2, down 1 over 2. Or we could go up 1 to the left 2. And there is our graph. So let's go ahead and graph that line. It would look something like this. All right, so that is that equation. So now let's take a look at this equation. Y equals 5/2 x minus 8. All right, it's already in slope-intercept form. So we have a y-intercept of -8. That means we can put our point at -8 on the y-intercept. And it has a positive slope of 5 over 2. That means we have a rise of 5 and a run of 2. So we would go up 1, 2, 3, 4, 5, and over 2 and put a point right there, okay? So I'm going to go ahead and put that point on the graph. So up 1, 2, 3, 4, 5, and over 2. And it's right there, okay? I could do it again, up 1, 2, 3, 4, 5, and over 2. And it would be right there. Okay, so we could draw this graph. And it would look something like that. All right, well, you can obviously see that where it intersects is here. My graphs don't show it exactly, but you see that at 2, -3 would be the solution. So our solution is a point. The x value is 2, and the y value is -3 right here. All right. And that is how you solve systems of equations by graphing.